I know.
Oh,
I know.
Sorry.
All right. Let's go ahead and yes, we're going to put on the hats. Okay. All right. Take one now. There's only one way that they can go on. But be careful with them. I mean, those are about, I can't remember, $80 to $100 a piece. Those yellow hats, yeah. So there's a fair amount of investment in these, and so we need to be very careful. Now, I was kind of nervous. Okay. Oh, you need. Okay. Has everybody got one in? Okay, a couple of them. Now, I was kind of nervous last year about these breaking off and so forth. They seem to be pretty sturdy, but I really think last year's class was very careful with them, and I asked them to, and I want to say the same thing to you. When you put them in, I mean, there's only one way that they can go in, but when you take them out, you want to be careful because the thinner end here comes out much easier because the thicker end is plugged into the calculator. So if you grab it on the thin end and pull, this end will come out, and I'm afraid that we're going to do this. We're going to break this off or break one of these off. And so when you take them off, and usually what will happen most days, hats will be out. You'll grab one, you'll put it on, keep it on the rest of the period. We may or may not use it. I mean, we may or may not even do anything wirelessly some days, but some days on the spur of the moment I want to do something or whatever, and I want it to be on and ready to go. But then at the end of the period, you'll pass these back around and you'll take them off. When you take them off, you want to grab on the thick end and be really careful as you pull them off, that you pull them off on that end, okay? So just something to please be careful about. Now, the first thing I want to do then is just kind of show you how this, oh, well, I wanted to get those things passed up. Are they all, did we pass those forward here? Okay. And, all right. Okay, so looking at the calculator and what this allows. Now, if you look down here in the corner, I've only got, it says one client connected. Now, if you would go on your calculator, hit the home button, go to the home screen. Okay, that's the on button, the top right. Okay, those of you that are just now messing with it here for the first time. Okay, and then we want to go to number 5, settings, and you should have number 6 should say network. Does everybody have that? Okay, if you bought your own, then, and if it does not say network down there in number 6, then your operating system's not up to the latest operating system. And I can do that for you. Okay, I can update that for you. Okay, but it'll probably still connect. So go to where it says network. You should see room 414 as an option. And go ahead and hit enter or choose that, and then it should help to connect. Now it says we got 7, 8, 9, 10. Okay, you probably see something up in the top menu bar, up in the very top row. It probably looks like something's happening there. You get kind of a blink, you get that Wi-Fi signal going on. If you're connected, there's probably a little check mark there. Okay, so now we got 18 connected. We're getting close. Now we're down to 17. Oh, what just happened? 18, 19, come on. Come on. 18. Well, now wait a minute. We're missing 2 though, aren't So we should only have 19. Okay, so there. All right, so 19. All right, now.
Mr. Clark?
Yes.
I'm not connected.
I think you are.
I'm not.
There's only 19 of us here, isn't there?
No, John too. That makes it 21.
No. We're supposed to have 21, and we're missing Nolan and Jeremiah.
Well, I'm not on.
We're going to find out here in a second. All right. So the next thing I want you to do is go back under settings to number 5, log in. Now, and we found out I messed up one person's, but your username, when you go to log in, your username should be the first 3, just like your school thing. The first 3 of your first name and then your last name. Now, there might have been a couple whose last names were too long, and I had to shorten them. Maybe not. Maybe that was the other class. Looks like maybe everybody's works. Now, the password is whatever you choose. Now, doesn't have to be the secret thing. It's just something you have to do. So, 555 or something. Just whatever you put in right now as your password is what it will be. Doesn't have to be real long or anything. Just something easy. And when you do that and hit log in, then your name should start to go bold here as you get logged in. Said attempt failed?
Yeah.
Oh, yeah, because I haven't began the class yet. My fault. So right up here, begin class, aha. Now try. Okay, Natalia is in. Steve, Matt, here we go. Yeah, okay, good. Okay, you can see the usernames down the side over here. Okay, Zach, are you in?
Yep.
See, so I think you were in. It just might have not have the same symbol, just that could be an operating system. But so we're good. Okay, who don't we have? Obviously Jeremiah with Nate is in. Okay, so all 19. Okay, all 19 of you are logged in. So that's why it doesn't matter which hat you have, but all the hat does is give you the wireless connection, and then when you log in, now we've got that calculated. Okay, so. Now, if somebody's back there messing around on their calculator and they're not supposed to be, not that I would ever use it for that. But the cool thing about this is we can pick somebody here randomly, and I can make this person the presenter. Now, I don't have the name listed here, so I don't know who this is. It is Riley. Okay, Riley is the presenter. So now whatever she's doing on her calculator, we can see, right? So I'll give everybody a chance here later to be presenter. All right. So that's one of the things we can do. Another thing we can do is what I'm going to do right now. Remember I told you how you can send me your questions that you might have and so forth. Another thing I can do is send little polls, little questions or things myself. We don't do this a whole lot, but it is something that we can do from time to time. Okay? So I'm going to send you one right now that I want you to do and I want you to send back to me. Okay, are you seeing something? Give it a minute. Did a little multiple choice question come up? Okay, go ahead and answer that. I'm not grading you on this, but I can see who answers what. Okay, this is what I see on my screen. Okay. The other class called those 16 people suck-ups. Now it says 0 submitted. You can still change your answer, but where it says quick poll, there's a little pull-down triangle. If you go up to there and hit submit, then that will submit your answer to me. So go ahead and do that. Okay? It is not a touch screen. It is not yeah, it's pretty cool, but it would have been a lot cooler 5 years ago before like the iPad and the iPhone and stuff, the touch screens. So it's still pretty cool, but it's not quite as user-friendly as that. Okay? And let's see who disagreed with that. Okay, Natalia. All right. Now we know. All right. Okay, so that's a little quick one. I'm missing one person.
I can't figure out how to get there.
It's not. Just use the last.
There we go. Oh, yeah. Oh, it's 80s.
Okay. Now let's do one more. Let's do one more here. Oh wait, I gotta stop that one. Start this one. Okay? All right, go ahead and answer that one. Okay, so again, all right, so that says a lot for obviously your motivation for signing up for this class. Okay, so we'll stop that. So anyway, that gives you some ideas, of various capabilities and so forth. Okay, let's take a look at that exploration number 2. Exploration number 1, excuse me. Exploration number 1, where we were looking at, and let's see, I guess I don't have that up here. Let's go to this picture. Here we go. All right. So here I've got a little representation of what we were talking about regarding the door swinging open. Now, where we left off yesterday is we were saying that if you were to do f of, we defined that function to be f1, didn't we, on the graph screen, right? Did you guys still have that on your graph screen, probably? If you go onto your scratch pad and your graph screen, you still have where you defined f1 of x to be 200x times 2 to the negative x, right? Even though on the paper it used t, we said we have to use x. Okay? Now, but what I want you guys to do, I don't care so much about the graph today. Okay? I'd rather have you in the calculator screen right now. Okay? Now, so the graph kind of looked like this. All right? But on your calculator, I would like for you to be on this. Now, remember how we got to that? For you guys that were, John that was gone, and those of you that just now got your calculators, this little calculator symbol over here is how you can bounce back and forth from calculator to graph screen. Calculator to graph screen. So I would like to have you on this calculator page right now. Okay? Now, I'm going to do something different because I'm ahead already on this. It's something we're going to be doing here in a little bit. So I'm going to do something that you should not need to do. If you, though, have not, you could do this. Matter of fact, this wouldn't hurt everybody to do this. You guys that were on the graph screen already, if you already have that equation entered on the graph screen, you would not need to do this. But if you just got your calculator today and you have not already went on the graph screen and typed in that equation, then you can do it right here on the home screen. We can define a function. So I just typed out the word define. Now, I could have went under menu, under actions, I think it's under actions, and I could have chose number 1, define. Okay? Either way would have gotten me to that. But I can define a function. Okay? So I'm going to call mine, I don't want to call it F1. Let's see, I need a space. The space is right down here by the Z. So if you want to do this with me, that's fine. If you just want to use the F1 that's in your graph screen, that's fine too, and I'll tell you what to do here in a second. I'm going to call this one, let's call this G of X. Okay, so I'm going to hit G, left parenthesis, X, right parenthesis, find my equal sign, which is up over here left of the 7. And then I'm going to type in 200x times 2, and then the power, remember, is over here left of the 4, the caret symbol, and then negative x. And then I'm going to hit enter. And it just says done. You did it. Okay, so now if you have any difficulty with that, let me know. So on the calculator screen, we can actually define a function. Now what that does for us is something that's kind of nice. Okay? Now, for those of you that didn't do this, and if you just left your function already in the F1, then your function will be, instead of G, your function is F1 of X. Okay? So when I type G up here, you type F1. You should get the same result. Okay? Now, where we left off yesterday is we were saying, here we had F1. Okay? This is what we did yesterday. And then we were writing, I think we had this on the board. F1 of 1.1 minus F1 of, what was it, 0.9? Didn't we have this on the board? And then we have 1.1 minus 0.9, right? And that came out to be what? I'm not sure we ever did the calculation. Did you guys do, did anybody do that? 30.870. And that was what? What are the units on that? Degrees per second. So that was how fast that thing was opening. Now we were trying to find how fast does that door open right at 1, right? And what we talked about yesterday is that's the main difference between algebra and calculus. With one of the groups in the other class, I was using this explanation. I said, if you drive from here to Grand Island, let's say you go 60 miles, and it takes you an hour. What's your average speed? 60 miles per hour. You went 60 miles in an hour. Does that tell you anything about how fast you were going at any instant along the way? No. You could have went 120 miles an hour to get it. Stopped, grabbed a sandwich, right, filled it with gas, and then went 130 miles the rest of the way or whatever. All you know is you went 60 miles in an hour, you averaged 60 miles per hour, but it doesn't tell you how fast you were going at any one instant. So algebra, this is an algebra calculation. This is really just a slope calculation is all that is. Okay? In calculus, we want to figure out what's the instantaneous rate of change. How fast are we going right at 1? So what we talked about yesterday is we said, okay, instead of an hour interval like we just talked about at Grand Island, that's the kind we would normally think about. Well, this is the same thing. This is a time interval from 0.9 seconds to 1.1 seconds. That's a time interval. How far did we go? Well, we plug 1.1 into this equation. That tells you how far the door was open. Plug in 0.9. That tells you how far the door was open then. Subtract them. That tells you how far the door went in that time interval. Divide it by 0.2 seconds, and that gives you the average rate in between there. And then we said if we keep shrinking that down and keep shrinking that down and keep shrinking that down, we still have a time interval, but it's a really tiny time interval. And we should be getting closer and closer to what the speed was right at 1 second. Now we can really see it easily on the calculator screen. Now, we were running out of time, and I didn't want to really just show you this just yet. So you probably had to get on the calculator screen, do some calculating. Somebody in the other class said they had an issue they tried to trace at 1.00001, and it was still giving them 100. Did anybody else have that issue? Because you didn't have enough decimals. It wouldn't show enough decimal places, right? That's why you want to come to the calculator screen probably to do that. Now, somebody in the other class also said when they came to the calculator screen, it was still showing them only 100. So maybe we should do this. Go up here to where it says the scratch pad, okay, with your arrow. About the only way, I think, is to go up there with your arrow. So use the touchpad and pull that down and go down here to settings and status, number 7. You can just hit a 7 or you can do the down arrow. And then choose document settings, number 2. And you should have float up here and not float 3. Yesterday we changed, in our graph screen, we changed it to float. But today we want it so it's in all of our documents. Okay? And it might be a good time to look at the rest of these settings and see if they're the same as mine. We want angle to say radian. We always want to be in radian mode. That's important. Not degree mode. We're hardly ever in degrees. Almost always we use radian. Okay? All right. So, and then you can hit make default. And then OK. All right. And then things should be good. All right, now here's the shortcut that I want to use. Now, since I've called this G, I'm going to use G. But if yours is in the graph screen, you could use F1 here. I'm just going to type exactly what I just had over here. I'm going to type this right here. Okay? Except my function is G, so I'm going to use G. So I'm just going to type G parenthesis 1.1. Now notice whenever you do a left parenthesis, it gives you right parenthesis, so you have to hit the right arrow to go out of it. And I'm going to do minus G parentheses, or G of 0.9. Oh, now I'm going to divide, and I'm going to run into trouble. I've never put parentheses around the whole thing, so I'm going to right arrow my way back to the far left edge, or excuse me, left arrow. The left arrow back there, I'm going to hit a left parenthesis. The beauty of this, when I hit a left parenthesis, it puts the right one automatically at the end there. But I got to encase that whole thing in parentheses. Now I'm going to right arrow all the way to the far end. I'm going to hit divide. And now in parentheses, I'll type 1.1 minus 0.9. You might say, well, why didn't you just type 0.2? Well, here in a second you'll see. But okay. Everybody see what I just did there? And then when you enter, the nice thing about it is then you get kind of nice math print on the screen. And so, yes, this is what I wanted. And sure enough, 30.870. Right? Degrees per second in that time interval. So then we said we should do what to get a more accurate answer? Narrow it down, right? So what I'm going to do now here's something. Once you get to this point, you can up arrow. We do this a lot on our calculator. Up arrow a couple of times until this is highlighted in blue. And then hit enter. And that will paste that down because you can't go back and change something, a calculation you've already done. But you can go up and grab it and hit enter and it'll paste it down there. And now we can arrow back into there. And I can change that to, let's put like 2 more zeros in there. Let's put 2 zeros. And that means we need 2 9s here also if we want to balance it on both sides. And then I'm going to put them in here. Put 2 9s there. And hit enter. And it's pretty cool. It's a pretty slick way to get that to change. Now notice it's fairly close. Would you feel pretty comfortable saying it's about 30.5? I mean, if you had to venture a guess at what is the speed right at 1 second, would you feel pretty comfortable with 30.5 or something like that? Right? You'd be in the ballpark, right? Depends how accurate you want to be. Well, we can be as accurate as we want to be, right? You want to be accurate to a couple decimal places? Well, let's keep putting in zeros. So let's put 2 more zeros. So 2 more zeros. Oh, whoops, can't do that. I just got done saying that. Can't change a calculation I've already done. I need to up and down there. There we go. I got to highlight it, hit enter, okay, and bring it down. Now I can stick in a couple more zeros, stick in a couple more 9s. Okay, hit enter. So what we're doing is we're saying, all right, we don't know how to do the rate of change at one point. We don't know how to do slope. This is really slope at one point, but we do know how to do slope at 2 points. So if we want to do slope at 1 point, let's pick 2 points really close to that 1 point. Really close. Infinitely close. And to be honest, if you could summarize calculus in one thing, and maybe I said this yesterday, it's that idea right there. That if we're trying to do things that we don't know how to do, let's take something that's similar that we do know how to do and do better and better and better approximations to get the thing that we don't know how to do. Which would, in this case, be we don't know how to do slope at 1 point, but we do know how to do slope at 2 points, so let's pick 2 points really close to that 1 point and get a better and better and closer approximation. Now, I feel pretty good about those first 3 decimal places, right? I feel pretty good about saying at 1 second, that thing was going 30.685 degrees per second. That's how fast that door was changing, because I'm in this tiny, tiny interval right around 1. And as I get closer and closer to 1, I'm going to just change out here in those decimal places down there. Okay? So there you go. So there's the answer to question 6. What's the instantaneous rate of change at t equals 1 would be 30.685 degrees per second. Okay? That would be a good answer for that. Okay? So that's that idea of instantaneous rate of change, something we're going to be talking a lot about over the next term. Okay? So remember, these worksheets, these exploration worksheets, are mostly about, well, the one we do today is mostly about just how to run your calculator, but the rest of the other two, the exploration 3 and 4 and this one here, are just about introducing you to the ideas that we're going to be working on. Okay? Not for you to understand them completely. Okay? And have to do them on the next quiz, but just introduce you to the ideas of what's going to be happening. Okay? All right. So, that's exploration 1. So the next thing I think we should do is, since we got the calculators here, let's just go to exploration 2. Go ahead and flip that over to the next page, and what we have here are some graphs. Okay? So if you want to delete out, okay, so I'll hit my scratch pad key over there. Okay, remember that scratch pad key on the left over here, that takes you from your grapher, not grapher, I never said grapher. Your graphing calculator, it'll take you from the graph screen to the calculator screen back and forth. Now I've already done the first one up here, okay? But there were a couple things we talked about yesterday. Now you've got 5 graphs you're going to do here. If you want to do one at a time and delete each one as you do it, that's fine. How did we say we could see the entry screen here? How did we say yesterday we could do that? Tab. So if I hit tab, now there's something else that I wanted to tell you here. Now I've already done all 5 of them. Okay, I put them all 5 in, F1, F2, F3, F4, F5. Now, when you hit tab, it opens up the next one that's empty. For me, is F6. Now you could up arrow, and I could up arrow, and there's F5, there's F4, there's F3, there's F2, there's F1. Now, the only one we can see is F1. Let me show you why. Okay, I'm going to hit, everybody look up on my screen here real quick. I'm going to hit tab again. And notice this thing gets dark right here. Now all this stuff I can do with my finger and the touchpad too. That gets dark. Okay? Little up arrow means there's another little menu under there. So if I hit enter right now, you can see, I can see these different, now I can up arrow to these different ones here. Okay? Notice how I've got a check in this box, and I turned off the check mark on these. So, because I didn't want to see all 5 of them at once, because it was a disaster, it was messy. okay? So I put 1 in F1. Now I could have just deleted, here's the delete key right over here above the 9. The diagonal from the 9, the delete key. I could have just deleted it and then type the next one in and so forth. You do it however you want. I don't care. If you want to see them all, have them all in there and turn them off as you go, it's up to you. If I hit tab again, it'll just tab a couple times, it'll close. It'll close it. Okay, you probably want to change your window. Notice on this worksheet, all the windows are from -5 to 5 on the X and the Y. Where do we find that? Under the menu, right? Now there is a little shortcut. If you hit Control Menu, Control Menu will just pop up a little kind of a right click. It's kind of like doing a right click. If you do Control Menu, it'll just pop up a little screen with the things that you're most likely to need. But if you just hit Menu, it comes up with this, and you go to Window, which is number 4, and you go to Window Settings, and I set mine -5 to 5. Okay, go ahead and take a little time here on this worksheet. Now, there is something you're supposed to do. You're supposed to draw a sketch of the graph on here, and then Part B says, tell whether the function is increasing, decreasing, or not changing when x is 1. If it's increasing or decreasing, tell whether it's changing slow or fast. Now, what's that mean, slow or fast? What did we say yesterday? What about the graph means it's changing slow or fast? How steep it is, right? The slope. If it's steep, it's changing fast. If it's flat, it's changing slow. So it's relative, okay? So that's what you're supposed to do on each of them. So we'll just take a little time here, get used to the calculator, do the graph. If you've got some questions about the calculator, please let me know. Okay? All right, so let's graph all 5 of these, sketch them on your paper. Now, on the second one, that sine graph, you should have parentheses around the pi halves and the x. Everybody realize that? Should look like, it should be that. Should be that. Now, if you're not getting a nice sine graph that does this, okay, then you're either in degree mode instead of radian mode. Well, that'd be the main reason. Unless, if you have the parentheses like that, then you should be getting a nice sine graph. So if you're not, let me help That's one of the bad habits from advanced math is writing sin x without parentheses, and even our paper did it. I'll always put parentheses around it because it's a function, sine of x, like f of x. And that's pretty good. There you go. That's pretty close, it's -6. So that's relatively close. And then what I would do is just trace. So if you go to menu, you trace F1, because they want you to know where it's going. I mean, it doesn't have to be a perfect graph, a perfect sketch. You don't have to plot a bunch of points, but they do want to know what it's doing at 1. So it might be good, you know, it looks like it goes right here at, looks like it crosses at 1. I think each one of these marks is a half. You know, you can put in a 0, see what the intercepts are, you know, make it a reasonable graph, but we don't need to spend all day on this either. Your sign should be a sign graph. If you're getting a line on number 2, then you didn't have parentheses with it, which is not your fault because it didn't on the paper either.
Yeah, that's on mine.
You got to have parentheses on that sign. Yes.
Or was it just a conversion?
Yeah, I mean, we'll see. I mean, yeah, turn it in. Yeah, better late than never, I guess. Yeah.
Can you update my one, or I guess when can you update my calculator because it's different than everybody else's?
Yeah.
Because I know when I've gone through some of the settings, they've been different too. And to get the check boxes to show me one of the graphs at a time is different because they're little eyeballs.
Yeah, you know, that's interesting you said that because I thought that was different too. Yeah, because see, what I remember from last year was this little thing to close
We had to. Yeah. Well,
See, mine has
yeah.
little eyeballs. And I have to click the eyeballs instead of the checkbox.
Right.
And when we were going through some of the settings up there, it was different than what you were
Right.
telling
Looked a
everybody
little
else to
different. Looked a little different. Yeah. It takes a little while. So I would say it shouldn't be that big a deal. You know what I mean? Right now. I mean,
Yeah.
I think you'll be fine. But because I am going to give you an assignment where you use your calculator tomorrow. You may not need it though the next day, so we might be able to hang on to it and see if we can stick it right in there and update it. It doesn't take very long.
Okay. So tomorrow,
What?
do I? Do you want me to
Let's-
just come in
here,
tomorrow morning
hang
and
on.
stick it in there?
Hang on here a second. Let me go ahead and keep working on that. Let me see if I can find. I might be able to just send it to you.
Okay.
I might be able to just send it.
Yes, you can. Okay, Zach, I'm sending it. Did something happen? Yeah, don't worry about saving anything. Just okay. Now yours is actually going to be just a little bit more updated than that. All right, how we doing? We done? Close to done? All right. So just you'll have to hang on there a little bit, Zach, on yours, and it'll. Uh-oh. Oh, great. Now I'm frozen up on everything else. That's okay. It hasn't shut down or anything?
No,
Okay.
okay. Shut down.
All right. So, okay. That's okay. We can, I don't think it's going to take too long. It's still sending. I think it's sending the file. Okay. While that's happening, while we're waiting for that, let's change gears here a little bit, and I can show you something else that we're going to need for our homework today. So let's shift to this, and you might want to jot a few notes down here. Now, I am still recording this, so I'm going to use my fancy markers here. And I showed you this yesterday, didn't I? This thing, okay. So I'll keep the screen on. You guys can tell me if I write something that's bad, or it's not, the marker's not working or something like that. So there's two things. We have like a 4-part assignment for tomorrow. Okay, one part you just done. Okay, this exploration. All right. Now there are two algebra things that we kind of need as we go throughout the year that we'll use quite a bit. The first one is interval notation. Okay? Interval notation. Interval notation. Okay. That'll use this for. So interval notation, we use a lot of intervals. Like we already talked about the interval from 1 to 1.1 or from 0.9 to 1.1 or whatever. Okay, we use that notation a lot. Now, when you first learn intervals in algebra class, you write it like this a lot. Something like that. That would be where x is between 1 and 3. And we include the 3, but we don't include the 1, right? That kind of thing. We hardly will ever write that. I mean, you can if you want, but that's not a notation we usually write. What we would write is this, like so. I think Mrs. Payne used that. I think in advanced math books, I think use that as well. So the open parenthesis means 1. The closed parenthesis, 1's not included. The closed bracket means 3 is included. All right? Now, you might say, well, wouldn't you confuse that with like ordered pairs? And usually not. I mean, in the context of the problem, you can tell if you're talking about an ordered pair. All right, if you wanted to write x greater than or equal to 7, okay, we would write that as left bracket 7 to infinity, right? Yeah, you can still write x greater than or equal to 7. It's still an okay way to write it, and if you write it that way, that'll be fine. But most of the time there are problems, you'll see it written this way. Now, never do a square bracket on infinity. You can't include infinity. That's always an open bracket. Okay, so that's interval notation. So we see that a lot. You're going to have some homework problems where they're going to give it to you in this kind of older, you know, this kind of less than, greater than kind of form, and they want you to write it in interval notation, meaning just with a bracket. So pretty simple thing. Okay? Also, intervals are given in absolute value notation a lot. Okay, not a ton in this class, but sometimes they are. Now, so I want to review that real quick. So if I had this right here, the absolute value of x minus 2 less than or equal to 8. Okay? Now, believe it or not, that actually determines an interval. Now, I'm not going to get, I don't want to get all bogged down in the algebra of how to solve this. And matter of fact, what I'm about to write right now, I'm going to mess with writing it. You're not going to have to do this. But the way you would work a problem like this is it's either an and or an or. It depends which way this is facing. This is an and. This is the way all of our intervals will be, this less than. And you would take off the bars, and it would be x minus 2 is less than or equal to 8, and x minus 2 is greater than or equal to, remember this at all? Negative 8, right? You'd flip the sign, you'd make it negative, and it was like two different inequalities. Now, if you add 2 to both sides, you get x less than or equal to 10, and x greater than or equal to negative 6, correct? And if you put that together, it would look like this. Less than or equal to 10, the 10 would go over here, greater than or equal to negative 6 would go over there. And then look, thinking about our new notation that we've learned, or that you've used last year, this is the interval from negative 6 to 10, including those. Okay, what I want to show you right now is a neat way where you can skip all that stuff in the middle, and you can just go from this interval notation down to here. Okay? And it may have mentioned this in your Algebra 2 books, I'm not sure. But if you look at this interval, if you look at negative 6 to 10, how wide is that interval? 16. What's in the middle of that interval? What's flat in the middle of from negative 6 to 10? 2. Oh, that's interesting. I wonder if that's a coincidence. How far is it on each side of 2? 8. Oh, that's interesting. Right? Whenever you have absolute value notation for an interval, it's x minus the middle less than or equal to what I call the radius. Right? Because it's 8 on both sides of the middle. So, anytime you see an absolute value notation, especially one that's a less than or equal to, it fits that pattern. Now, unless you had like a 3x or something there, and you'd have to factor up 3. But when we're writing intervals, we never do that. It's always x minus the middle less than or equal to radius. So if I was doing this problem and I had these bars, I would just say, okay, 2's the middle, and I got to go 8 on either side. So if I'm here at 2, I go 8 this way, that's 10. I go 8 this way, that's negative 6. My interval's negative 6 to 10. And I don't have to do any of this stuff in the middle. Okay? And then likewise the other way. If I want to write this interval in absolute value notation, I need the middle. That would be 2, that goes there. And then 2 is 8 either way, and that goes there. Okay? So that's the first thing. So you have some homework problems that will ask you about absolute value notation. What's the interval? Here's an interval. What's the absolute value notation? And just kind of go back and forth with this right here. Okay? Not too tough. All right, the second thing I want to talk to you about is lines. Linear, how are we doing? We off the screen yet? Linear equation. Zach, how's the calculator coming?
That's good to go.
It's done? Okay. All right, so linear equation. Now, we're talking about y equals mx plus b, you know, that kind of stuff. Slope, right? So if I told you that m equaled 2, the slope of a line was 2, and it went through the point 1, 3, and I asked you to write the equation of that line, and we do this a ton, it needs to become just automatic. Now, I'm going to give you what I think is a simple way to do it, and I've convinced Mrs. Andreessen to teach it this way in Algebra 2, Honors Algebra 2, but I'm not sure she did what you guys are coming to. Okay? Tell me how you guys would do this. I mean, just throw, there's a couple different ways you can do it. Remember any of them? To write the equation? Okay? Oh. Well, if I gave you 2 points, you would want to find the slope, right? You pick one of them. What do you think? Yes. Well, there's the y. One method is the y equals mx plus b method, right? Where you got y equals mx plus b, and you put what in for the y? 3 for the m, 2 for the x, 1, and then you figure out what b is. Okay? So 3 take away 2, so b would equal 1, right? And then you plug it all back in and you get y equals 2x plus 1, right? That's okay. I call that the y equals mx plus b method. Were you thinking something different? That's what you were thinking. That's one method. Okay, there's a method that I know Mrs. Andreessen used to do with using just the regular old slope formula. I don't know if she did this when you guys were in class. So she would take the 2 and put it in for the m. And since you only have 1 point, she would put that in for y1, x1, and then this she just leaves. So she'd go y minus 3 and x minus 1. Does that look familiar at all? Okay? And then you can multiply the x minus 1 over here. So you get 2x minus 2 equals y minus 3. And then you'd add the 3 over there. So we add 3 to a negative 2, that'd be 1. So you get y equals 2x plus 1. There's that. Now, to be honest, I don't like either one of them. Okay, I mean, there's nothing wrong with it. But I like this one. Now, the book's always taught it this way, and I've changed it just a little bit. The book's y1 or y point, something like that. It's called the point slope form. Okay? Does that look at all familiar? Maybe, sort of, not much. Okay? Well, what I'd like to do is take this form, which is really all it is this. Look at this, guys. All it is the slope form, and I just take the x2 minus x1, I multiply it over here with the m. Right? I mean, that's all it is. Okay? But what I'd like to do is do one more step and add the y over to this side. So I'd like to write this y equals m x minus the x point plus the y point. Now, if you guys would memorize that, and it's not hard to do, this will make your life much easier this year than trying to do one of these methods. Now, if you love y equals mx plus b and you're good at it, go for it. That's fine. But here's how you would do the point slope form. This is the way you'll always see me do it. Okay? Is okay, I got my slope is 2, so I'm going to stick that in for the m. And I got my 0.13, so I'm going to go x minus my x point, which is 1, plus my y point. Now, you might say, well, that's not that much faster because now you got to distribute, right? So if I distributed this and simplified it, I get right down to this. You say, well, that's not any easier than this. But here's the beauty of it. We don't even have to simplify. On the AP test, if they ask you for the equation of a line and you leave it like that, that's fine. You do not need to simplify. Okay? This is perfectly acceptable. So I'm saying, why not use that? Because there wasn't any work to do, really. I just had to take my m and put it there, take my point and put it there, and I was done. And so, to me, it made these a lot more work. So my suggestion is writing an equation of a line, memorize this point slope form, because that's what you need to write the equation of a line. You need a point and you need a slope. Now what if I had given you 2 points? And do the slope, right? You do the slope formula, find the slope, and then choose one. And now, so one person's might look different than another person's because they chose a different point, but if they would distribute it out and everything, it would simplify the same. So they really are the same, even though they would look different. So if I give you 2 points, and that's going to be part of your homework tomorrow for the ball, is you have 2 points, find the slope, and then choose one of the points and the slope, plug it into this, there's your equation. Okay? So those are 2 things from algebra that we see a lot in calculus this year, and so I want you to be able to work with that and do that. Okay, let's come back to our thing here. Okay, successfully transferred. That's the first time I've done that. That'll work kind of slick. Okay. Cancel. All right, so now we're back to our graphs. So, here, how fast was this? This was increasing or decreasing? Decreasing, right about here, right? And it was slow or fast? Yeah, I mean, it's relative, right? It's faster here than it is down here later, but it's fairly slow, it's fairly level, it's fairly flat, not real steep, right? The steeper it is, the faster it's going. Okay, and if we, okay, so if we look at some of the other ones here, all right, let's turn off that one, turn on this one. Okay, here's what your sine, Okay, there's what your sine graph should look like. What did you say here? Increasing, decreasing, or not changing? You sure?
At 1.
Isn't it right at the top at 1? That's not changing. If I go to 1, there's 1 right there. That's not either one. That's not increasing or decreasing. It's changing, or, well, it's not changing because it's switching between the two. It's, okay, at the very peak. Now, we will have a name for that. We'll call that a local max. We'll call that a local max of the function. But we would say it's not doing either at that point. Now, it's about to start decreasing, but at that point, we would say it's neither. Okay? All right, next one. Now, another thing about this worksheet is these are, Okay. Another thing about this worksheet is this is a variety of what we call families of functions. You are going to need to know what the basic graphs of some of these things look like. You need to know that when you see a quadratic, it's going to be a parabola. You have to know that first one, when you see 3 to the x, that it's an exponential curve. You need to know what the sine curve looks like, okay? Because on the no calculator parts of our quizzes, you know, it asks and we talk about functions. And knowing what their graphs look like is sometimes the only way to be able to answer the question. And last year, I know you talked about shifting, right? Remember that? Phase shifts, like vertical shifts and stretching, compressing graphs. We got to know about that stuff, okay? So we'll be reviewing that and looking at that as we go along, all right? So that's another reason we're doing this right here. So there's just a basic parabola. At 1, of course, this is going up pretty steep. I'd say this is changing pretty fast. Obviously, it's increasing, okay? All right, let's go to the next one here. Number 4, the secant graph. Now, I don't know if you remember this, but the secant graph was the reciprocal of the cosine graph. So right here, it's undefined. Well, that's where the cosine graph is 0. And so if you do the reciprocal of 0, it's undefined, 1 divided by 0. And so there's your cosine graph underneath there, and secant's the reciprocal of that. Okay, and so that's why the secant graph looks like it does. Now, we don't do a lot of work, I'll be honest with you, with the secant graph. Most of what we do is sine and cosine. Okay, if you're comfortable with those, that's pretty good. All right, and at 1, what was this? Was it undefined? It's undefined. What happened when you traced there? Did it just give you nothing? If you type in a 1? Oh, no, I guess we get a value. Yeah, we get a value, right? So it's increasing, all right, and I don't know, slow, fast, kind of in between. I don't know. I mean, that's not really a great question. Is it slow or fast? Because it's kind of relevant. All right, so let's keep going here real quick to the last one. And 1 over x. Can anybody tell me what this shape is? You guys studied them last year. Starts with an H. It's a hyperbola. It's a hyperbola. You never did any that were slanted like this, though, I think. You always had the hyperbolas that opened left, right, or they opened up, down, right? But this is kind of a diagonal hyperbola, okay? But it's a graph of 1 over x. So that's another basic graph. Those you kind of know. If we see 1 over x, that is that hyperbola in the first and third quadrant. Okay, and at 1, you're right kind of in the middle here. Kind of, again, it's decreasing. All right? But anyway, that exercise was mostly about just being able to get on our calculator, draw some graphs, set a window, look at the menu, do those kind of things. Okay, the last thing I have to show you, and this is kind of, hopefully you'll find it kind of fun. So I said the homework was 4 parts, okay? One part is that little exploration, those graphs. So you're done with that. The next 2 parts are on this sheet right here. This is your chapter 1 assignment sheet. You want to hang on to this all throughout chapter 1. So when I assign you, when I assign you something, this is the sheet that tells you which problems to do. So if we're sitting there and say, okay, tomorrow you do 1.7 homework. Well, you go down here, you find 1.7. Well, there's day 1, day 2, and you'll know which one of those to do. For tomorrow, you're to do the problems where it says Appendix B. Now that's in the back of your book. See where it says Appendix B? Just put a little star by that or circle it or whatever. Those are problems dealing with these intervals, absolute value and stuff. Okay? I said there were 4 parts. That's the second one. Third part of the homework is Appendix C. Those are some problems with writing equations of lines. Okay? And the fourth part of your homework I'm going to send you on your calculator. And that's also writing equations of lines, but I think it's, like I said, hopefully you'll think it's kind of fun. So 19 people still logged in and connected. That's good. Okay, something should be happening here shortly. Maybe. Soon. It's thinking. It's thinking. There we go. There it comes. It's turning green. What's happening? Nolan and Jeremiah aren't here. All files have transferred. Okay. So, all files, okay, so this is new. This didn't say this last year. All files have been transferred. Just hit close. Just hit close. I mean, it doesn't matter if you have one or the other. You guys are ready? All right. If you hit close, you should be on the home screen. Now, here's what just happened. Okay? I sent you, okay, if you're on the home screen, I told you that 90% of the time will be in here in the calculate and graph on the scratch pad. But I just sent you a document. Okay? Now, if you want to create a document, which you will hardly ever do, that's one. My documents is like your hard drive. That's where things are stored. Current is whatever, the current document you happen to be working on. And then, of course, there's the settings. So if you go down to number 2, if you hit number 2, My Documents, now yours looks different than mine, but you should have one called Golf Course Holes 1 through 9. That's what I just sent you. Now on mine, I'm just going to go to current because that was the last one I had open. Okay? Is everybody seeing this now? It's under the AP Calc period 3. I'm sorry, it's under that folder. There you go. You have to open that folder, which you can hit enter or right arrow. And it says Golf Course Holes 1 through 9. Yeah, it created that folder, that AP Calculus period 3 folder. Okay? And now you open that and you should see this, right? Let me know if you don't see it. It's loading. Okay, it's loading. It takes a little bit. Yeah, it takes a little bit, but the clock runs on it or whatever. Okay? and you should get to this. Now, I want you to notice something about a document. It's got these page numbers up here. Okay? So, okay? Actually, the reason there's two numbers there is the first number is like the problem number, and then the second number is like the page within that problem. Okay? So 1.1 is like the introductory screen. Now, to go across here to the different pages, you can either click with the arrow or you can hit Control right arrow. If you hit Control right arrow, okay, it'll take you to the next screen. Everybody seeing the golf course picture? Okay. All right. Now, the directions are down the left-hand side. So if you arrow down here, if you arrow down, okay, you've got two golf balls here, two white dots. Well, you've got the white dot for the golf ball and the white dot at the hole. You want to make the ball in the hole. Now, this isn't Xbox. There's not going to be cool animation. You're not going to swing the club or anything, but it's still kind of cool. So here's the problem. The hole is at 7, 1, and the golf ball is at -7, -6. You need to write the equation of the line to connect the ball to the hole. So let's do that together real quick. So let's do that slow. Now you either have to go back to your scratch pad if you want it, if you need to do it, but maybe you can just do it on paper. It's pretty easy. So we do our slope calculation. So -6 take away 1, and now we subtract our x's. -7 take away 7, and that's -7 over -14, which is 1/2. So our slope is 1/2, right? Now, if you wrote down the thing, if you memorized the thing that I told you here, right? The equation of our line, if that's our slope, is y equals 1/2 parentheses. Now let's pick the point that's positive. That'll make it easier. Let's pick 7, 1 as our point. So I'd have x minus 7 parentheses plus 1. And that's it. I can just stop right there and I'll type that in. The calculator will simplify it for me. Calculator will understand that. So I arrow down to where I'm in the box here where it says y equals. They already have the y equals for you. So I'll go 1/2. I could just put 0.5. That'd be easier. Parentheses, x minus 7. Then I have to hit the right arrow to get out of the parentheses. Plus 1. You can see it's already putting the line on there for me. And there it is. And the line goes through and I made it. Okay? Now, you don't have to save it. The little asterisk up there means it hasn't been saved. You're not going to lose anything. When the power goes off, you turn your calculator, you come right back to it. But you can hit Control S to save. So if you hit Control S, it says saving. Then there it is. And so then you hit Control right arrow, and that takes you to the next hole. It's a new picture, new hole. Okay, so do all 9 holes. So that's the last part of your homework. Do all 9 holes, and then tomorrow when we get to class, put the hats on, and then I'll collect them, and then I can grade them, right? Okay, but anyway, I'll collect them and see how you did and so forth. Okay, so you already did exploration 2. You got appendix B and C, and you got the 9 holes to do. All right, you got the rest of the time, 10 minutes, whatever it's worth. Okay, now, and listen, the hats are on there so I can send that stuff to you. You've now got the document, right? So you can do this at home. The document's on your calculator, the golf course thing's on your calculator. So the hats don't matter at this point. Matter of fact, you can take them off. It'll at this point we're done, you can just take them off and essentially that logs you off. It doesn't hurt anything, to pull those things off. Just be careful with them when you do. Okay, but now that document's on your calculator and you can work with it. Go ahead and just pass those back. Grab a couple of them and just pass them around. Be fine.